So that was the first 5. Let's do the second half now. Alright, so we start off, we've got Marcus, and he wants to find the perimeter of his shape below. So we've got a rectangle that measures that, 2 congruent isosceles triangles, top and bottom. Remember, isosceles means 2 sides are the same, which means if this side is 10, then that means that this side over here should be 10 as well. So I can fill that in. And since it says there's a pair of congruent triangles, that means that these sides down here should be 10 as well. So that gives us that. Then it says we have 1 pair of equilateral triangles. And let's assume that those are these here. We knew that this one couldn't be an equilateral triangle because we have this 17.3. So obviously all 3 of those sides can't be equal. So that means that this is 4 and this is 4. And again, it's 1 pair of them. So we have over here, this would be 4 and 4 as well. And that's it. That's all we need to know. Because remember, perimeter just means around the very outside of the shape. Just the outside. So I don't really care about this rectangle in the middle. So I'm not even gonna look at these formulas. I'm just gonna add this up. I've got 4 10s. So that's 10 plus 10 plus 10 plus 10. So all those blue pieces add up to 40. I've got these green ones. There's 4 of those. 4, 4, 4, 4, and 4. That's a total of 16. If we combine that together, we get a perimeter of 56. And I'll leave it up to you to figure out which of those equations matches what we just did. Okay? Alright. Number 2. A box contains 15 packages of cereal. So we've got boxes in our boxes. The weight of the empty box is 19 ounces. Total weight of the box with the package is 499 ounces. Which process can find the weight of 1 package of cereal? So what kind of cereal is in our box? Take a minute to imagine what kind of cereal you want. Okay, you got it? Okay, now it's Trix. That's what was in the box. I'm sorry if you don't like Trix, but Trix is pretty awesome. So that's your new favorite cereal. Okay? Your favorite. Go out, go buy a box of Trix. Alright? And then we can answer the problem. So how do I know how much this 1 box weighs all by itself? Well, there's 15 of them. And so I'm going to have to multiply the weight of this box times 15. And that'll give me the total weight, except there's one thing we need to add to that. So there's the weight of the empty box. So that sort of matters. When we're weighing this, we need to consider the weight of this box. So if this is 19 ounces, we can say, what is the weight of all the cereal boxes inside of it? Well, we can say that's 499, so we would need to take away the weight of this box, because that has nothing to do with the cereal. And then I'll let you think from there about what you would need to do with that leftover number to get the weight of this 1 box of cereal. Okay? Just think about that and eat some Trix. Alright, number 3. Larry spent 44, whatever, school supplies, backpack, blah, 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 all that. Alright, how many folders did he buy? So we kind of have to work a little bit backwards here. So he spent $44.25. That's how much money he spent. So we got to figure out, where did that money come from? So we can say, if we let's add up everything that we know that he bought. So he bought a backpack for $12.50. He bought paper for $6.75. And he bought pens and pencils for $5. And I'm going to fill in a couple zeros there, because when we add these up, we want all our decimals to be lined up. If we add that together, 0, 5, and 0 makes 5. This is 12, carry the 1, bring down our decimal. That's 8, 9, 14, 24. So we can say he spent all this money, so we can take that away from the total. And that'll give us the amount he spent on folders. And to know how many folders he bought, we say we take that number and we divide it by the cost for each one. So we divide that by $4. And from there, that's just academic. I'll let you work that out. Okay? Number 4. This one was a little tricky. First of all, because the lady's name is Nora. What kind of name is that? Second problem is she's buying stamps, and I don't know who buys stamps anymore. And she buys like a lot of them, which just complicates it. So she bought 43-cent stamps, books of 20 and 30. She bought 3 books of 20 and 4 books of 30. Which, if you add that up, is like, what, 180 stamps? Who needs that many stamps? That's crazy. So let's figure it out. What we need to remember is even though you buy them in a book of 20 or 30, you're still paying 43 cents for every single stamp you get. So when she says she buys 3 books of 20, we're saying how many stamps is that? So that's 20 times 3 books. So that's 60 stamps right there, and each of those costs 43 cents. So we're going to have to take 60 stamps times 0.43, and that'll give us the cost of our books of 20. And then she also bought these, she also bought these books of 30. She bought 4 of those. So we're going to do the same thing. So this time it's 30 stamps times 4. So that's 120 stamps that she bought. And all of those still cost 43 cents. So we're going to have to work that one out. And when I say we, I mean you, the individual. Okay, and then once we have the total of the blue stamps plus the purple stamps, we need to add them. So our final answer is going to be the blue stamps plus the purple stamps. So sort of a lot of math to do there, but that's the basic layout. So if you're picking your equation, you got to think which of these matches what we did here. So multiplying and then adding. It's one of these. Pick carefully. All right. And number 10, Mrs. Johnson paid $4.85 for a long distance phone call. She paid a fee of $1.35 plus 35 cents per minute. Which equation can we use to find x, the length of the call in minutes? Alright, so we can figure this out. We start, as always, when we talk about fee questions like these, we start with the flat fee. So she's going to pay $1.35. There's no getting around that, right? I don't know if I just want to give you the whole answer for this one. Sure, why not? We'll see who actually watched all the way through. So it's $1.35 plus, that's the flat fee. She also paid this cost per minute. So it's going to be 35 cents times however many minutes it is. So it's 0.35 times the number of minutes. And the number of minutes, it doesn't tell us, it just calls it x. It's just going to be 0.35x. When we add those together, it gives us the total cost of her phone call, which it gives us as $4.85. So there's that. And you can find the equation hopefully from that. If you actually wanted to work it out from here, and I understand we didn't get to do a whole lot of these, we want to get this number all by itself. So we need to get everything away from x. So we're going to take away this $1.35 charge. And that means if we take it away from one side, we have to do the same exact thing to the other side. So this cancels out. This is 0. 485 minus $1.35 is, that'd be 0.53. So at 35 cents a minute, costs $3.50. So what this means, what we did here is we took away how much she paid just initially. So if we take that away, this is how much she paid just for the minutes she used. So from there we can see, well, 0.35 times what gives me $3.50. And hopefully somebody said 10. If not, we can do the opposite of multiplying. We can kind of work backwards here. And we can divide this by 0.35. Okay? And this sort of gets into what we did last year in dividing decimals. We say 3.50 inside, 0.35 outside. We never want to divide by decimals because it's not fun. So we move this to make it a whole number. So if I move this over 2 places, I get the number 35. If I move this over, we get 350, and then it's just a question of how many times does 35 go into 350? And which you'd say, duh, of course it's 10. That's it. That's how many minutes you spent on the phone. You could work that out backwards and say 10 times 35 cents plus $1.35, and you would end up back at $4.85. All right? So now that you've corrected these ones plus the first 5, you're all set. All right. So have a good evening and eat some tricks.